All right. Variables on both sides of the inequality. This is the next part of 2.4. This is solving an inequality with more than one step. So, Grace, when we have more than one step in inequalities, we could have multiplication and addition, division and subtraction. We can have like two operations going on. The other thing we can have going on, Grace, is we could have more than one variable, okay? So we could have variables on both sides of the equation. Now, we went over that in this class, right? Maybe like a month and a half ago. Vaguely remember? You could say no. I don't really remember what I had for breakfast yesterday, so it's okay. So, Grace, when we have variables on both sides, funny things happen. And by funny things happen, I mean we could get an answer. So in this case, what were the three possible outcomes? Well, we could get an answer. And what do I mean by this? Well, in this case, we would have like, like x equals 3. That was the stuff we were doing earlier. X equals like -2. X equals 12. Okay, with inequalities, this would be something like x is less than 3. Or something like x is greater than or equal to -5. Okay, so this is what it looks like when we get an answer. All right, now there's two other possible outcomes. One, we could get no answer. Well, what does no answer mean? Well, this is when something failed, like we had x plus 1 equals x plus 2. No matter what number I plugged in, would never balance out. Because if I add 1 to something and add 2 to that same thing, well, there's no way it could balance out because one side was larger and would always be larger than the other side. And in this case, okay, with inequalities, we will get something like this. 13 is, let's say, less than, let's go with a nice easy number, 0. Now 13 is not less than 0. This is false. So that's why we would get no solution. Or we could have like -12 is greater than or equal to -2. And this is no solution. Now, one thing I want you to notice is that when we get an answer, we have x's left over. When we have no solution or no answer, notice there were no x's left over. It was just numbers, okay? And finally, we could get infinite solutions. And this would look something like, well, 0 equals 0 when we were talking about equations, or 2 equals 2. But with inequalities, this is going to look something like 5 is less than or equal to 6. Notice that's true. I have no x's, and 5 is always less than or equal to 6. Or I could have 7 is greater than -2. Notice that's always going to be true. So with inequalities, things are very similar to equations. So in short, we could get an answer for us. That's going to look like these over here. All right, we could get no answer, which means we get a false statement where something's not balanced. Okay, there's a fault in everything. Or we could get infinite solutions, which means no matter what I plug in, I'll always get the same answer. Now, these directions, and these are the difficult problems that we have, these are multi-step. So we're going to have more than 2 steps. So what we have here is we have a lot going on with the problems. So we have to break them down. Now, Katie, how are you? Doing all right? You seem a little tired. Are you a little tired? Gotcha. Well, I'll try to make this short and sweet here. Katie, if we look up here in problem A, there's a lot going on. Agreed? Now, if you look at A, where do your eyes go? What's the first thing you see when you look at problem number A? You see the X's and what else? The parentheses. And I agree with you. My eyes are drawn to the parentheses. So the first thing I want to do, Katie, is get rid of those parentheses. Now, I could try to divide both sides by that 7, but that's not going to really help me out here because 7 doesn't go into 5. So let's go ahead and distribute that 7 in hopes to get rid of the parentheses. So on the left side, I still have 14x plus 5 is less than 7 times 2 is 14. So I have 14x, and 7 times negative 3 is negative 21. So now I have this. Neat, do you see that? Okay. Now, some of us, okay, are going to be able to see this right off the bat, like Jules. Jules is going to be able to see this from here. She's going to say, Harmon, you got 14 x's on the left and 14 x's on the right, and you're adding 5 on the left and subtracting 21 on the right. Something's going to be happening here, all right? And you're going to notice, well, if I add 5 to something and subtract 21 from that thing, well, it's not going to be balanced, okay? And in short, if I add and I subtract, this side on the left is going to be larger than the side on the right. So Jules is already starting to notice, hey, I'm thinking there's going to be no solution to this because of this. If I subtract 14, if I subtract that 14 from both sides, is 5 less than negative 21? And the answer Jules is going to tell us is no. And she can probably see that early on. So we would write no solution to this. Because no matter what number I plug in, it's not going to balance out. How can I add 5 to something and subtract 21 from it and expect one side to be larger than the other? It's just not going to work out in this case. All right. Grace, with B, where are your eyes drawn? Where do you, when you look at problem number B, the parentheses, and that's where my eyes go to again with this problem. And my eyes typically go to the parentheses first because I want to get rid of them. They make my problem look harder. So I'm going to distribute that 6. So I have 12x minus 1 is greater than 6 times 2 is 12x minus 6. Are you with me on that, Grace? Now, I know Ellie's starting to get this, and Ellie's saying, well, Harmon, you got the same number of x's on both sides. And I'm going to say, yeah, you do. And on the left side, we're subtracting 1, and the right side, we're subtracting 6. So I'm starting to feel that, you know, this thing might be infinite solutions. So if I subtract the 12x away, I have negative 1 on the left is greater than negative 6. And notice that's true, whereas this one was false. 5 was not less than negative 21, it was greater than. But here, negative 1 is greater than negative 6, so this is infinite solution. Ready, Nate? All right, so we got 3 problems here. And the one thing I want to do is I want to get all of the variables to one side. That's the goal. Okay? So number 4, do you want to move the 5x or the 3x, Nate?
3x.
Good, I agree. I want to move the 3x because it's smaller than the 5x. So I'm going to go ahead and subtract that from both sides. So 5x minus 3x is 2x. So I have 2x minus 12 is less than or equal to. The x's cancel, and I have minus 4. Now notice, Nate, see how I have x's still left after I moved all the x's to one side? This is going to tell me that because there's x's left, I'm going to have a solution. Okay? You got that? Now I still have to go and find that solution. So how would you move that minus 12?
Add 12 to those.
So let's add 12 to both sides. And that's going to give me 2x is less than or equal to 8. Then what, Nate?
Then I divide both by this.
And get?
X is less than or equal to 4.
So now I have to graph this. So I like to put 4 in the middle, 5 and 6 to the right, 3 and 2 to the left. It's going to be a closed circle. I'm not eating the xy sheet to the left. Easy enough? Mike. Mike. Mike, what would you want to do with number 5?
Subtract 5.
Subtract? What do we want to try and get rid of first here?
Do 5m and then 5 plus 5.
Close. We're going to do the 5 times m and the 5 times 5. I think you said plus.
Yeah, I said that.
Okay. So we have 5 times m, that's 5m, and 5 times 5 is 25. So that leaves me with this, Mike. Now what, Mike?
25 divided by 5.
Well, we're not at that stage yet. The stage we're at is we want to get all the m's to one side. So how do I move a plus 5m?
Subtract it.
So let's subtract it. And I have 25 is less than 17. Is that true or false, Mike?
That is true.
25 is less than 17?
Oh, I thought it. Nope, that's not true.
Not true. So this is no solution. All right. And I think we can kind of guess what the last one might be here, right? We have a solution, no solution. Who wants to take a guess at what this one is? Anybody? Even on my birthday. Infinite solution.
Infinite.
So I'm kind of thinking it's going to be infinite solution, right? Because I'm probably going to show you all of them. So here, John, what would you do first in number 6? John? John? Oh, John. All right, let's go with Chucky. Chucky, what would we do first?
Huh?
What would we do first here?
Number 6.
Yeah, what would we try to get rid of?
8 or
Well, not
the
yet.
four
I'm trying to get
two.
rid of those parentheses. So I'm going to distribute that -4. So when I do that, on the left-hand side, I don't change anything. I have 1 minus 8s is less than or equal to -4 times 2s is -8s. -4 times 1 is +4. Now, Chucky, how do I get rid of -8s?
Add
Add 8s. So I have 1 is less than or equal to 4. And Grace already told me she suspected that this was going to be infinite solution. And do you see how you confirmed that it was? So infinite solutions or solution. How are you guys feeling? Kind of like, yeah. Don't worry, I'm not going to have too many on the test of these. Let's see what we got next.
Wait, hold up. When's the test?
Probably next week. All right, so here's what we're going to do. I'm going to stop here.